Hey, ladies and gentlemen. So, formative 1.1, that first formative we took last week. For this one, we were looking at the fact that there are 92 naturally occurring elements that exist in the world. However, not all 92 elements can be found in their pure form. Only about 80 of them can. This is due to some elements being stable and others being more reactive. So, that is the overall concept of what we're trying to learn in this unit is that some elements are more reactive than others. So we're going to figure out which ones are more reactive and which ones we can find in their pure form. When we're looking at our stable elements, there are ones that we can think about in our everyday lives, maybe gold, silver, copper, and the number of valence electrons helps us to determine the stability of our elements. Juan is starting his job at Chem University, trying to determine if elements can exist in nature by themselves or would they be too reactive. He'll be using his knowledge of the structure of an atom, element's reactivity, and Lewis and Bohr models to determine their reactivity. And so what we're trying to do in this specific formative is we're examining nonmetals to look at their subatomic particles. And what we're going to do is we're going to look at the 4 sulfur, oxygen, fluorine, and chlorine specifically, and we're going to compare their subatomic particles. So if we take a look first at fluorine versus chlorine. So these two are both elements on our periodic table. They're actually both in row 17 or column 17 or group 17. And so if we look, the first thing we need to do is figure out the number of protons, neutrons, and electrons from both. So if we look at protons, that's going to be our atomic number or our number up here. Your guys is in the middle of your periodic table, but it's going to be 9. And we know that because we want a neutral atom, the protons are going to equal the electrons every time we start one of these. So our protons equal electrons, so 9 equals 9. And so now we know how many electrons as well. The neutrons is going to be the hardest one to figure out, and that's going to be our mass number, which we round to the nearest whole if it's not already there. So our mass number minus the protons gives us the neutrons. So in this case, we're going to take our 19 minus the 9, and that's going to give us a total of 10 neutrons. All right, so now that we have our protons, our neutrons, and electrons, we have to remember where they go. And if we remember correctly, this one, the protons go in the nucleus. The neutrons are also in the nucleus, which remember is just the center of our atom. So it's that middle circle that we draw, labeling it that those are where we find all our protons and neutrons, all of our mass really. And then our electrons go in our orbitals, or those rings that go around the nucleus. So now that we know where they go, we can actually go ahead and draw them on our Bohr model. So first we draw our lovely nucleus. Remember, the nucleus should be its own circle. We don't attach it to the rest of them. So writing it little tiny just so I can make room for everything else. But I have my neutrons and my protons in the center. I'm just going to change up slightly. And so now we're going to go with our first orbital around the nucleus. And so if we remember correctly, our first orbital only gets 2 electrons and then it's full. And we remember that because there's only 2 elements in the first row, and each row tells us the number of orbitals that we have. So there's only 2 electrons in the first row, and we need 9, which means we have to add a second ring around the nucleus to add more electrons. So we added a second ring, and so we need a total of 9, and we've already used up 2, which means we only need 7 more. 4, 5, 6, 7, for a total of 9 electrons on our atom. So we can see there's 9 total. There's 7 on the second row or second orbital. It's 2 on the first ring or orbital. Okay, we can do the same exact thing, but with chlorine. But chlorine this time has an atomic number or a proton number of 17, which means our protons are going to be 17. And that means one other thing is going to be 17. That means our electrons are also going to be 17 because remember, our protons and electrons should be the same thing. Now our neutrons are going to be a little bit more difficult because now we actually have to round this number. It's not a whole number already. And it's a 4 right here that tells us that we just get rid of our decimal and we leave it as 35. It was a 5 or higher. That means we do have to round up to the next whole number, which would have been 36. But so we can, if we can round this to 35, that means we do 35 minus 17 because it's mass number minus protons, and we get a total of 18 neutrons. Again, now we have to draw our nucleus. And we put our elements in our nucleus. So I have protons, which is 17, neutrons, which is 18. And that goes in the nucleus. And now we need 17 electrons on our orbitals. So the first row or first orbital or first ring gets only 2 yet again, only ever 2 electrons. And now we got to move to our second ring, our second orbital. In the second orbital, that one can get a total of 8. Remember that we have 8 elements in the second row, which means we can have 8 electrons. So 1, 2, 3, 4, 5, 6, 7, 8. But we are not done because that's only a total of 10 electrons and we need 17, which means we do have to make a third orbital or third ring around our nucleus. And this one will get the rest of our electrons, the extra 7 we need. So 1, 2, 3, 4, 5, 6, and 7. All right, so now that we have both of those lovely drawings, we're actually going to compare them to each other. So we want to compare the Bohr models to one another. We have to find at least one similarity and 4 differences. If we're looking for our similarities, one that we could always talk about for these two is because they're in the same group, that same column, and we count, we have 1, 2, 3, 4, 5, 6, 7 valence electrons here. And 1, 2, 3, 4, 5, 6, 7 valence electrons here. So a similarity they have is both have 7 valence electrons. So that's our similarity. If we wanted just one, we only needed one. Now we can talk about our differences. And if we're talking about differences, we have the difference in the number of protons, the number of neutrons, the number of electrons, the mass number, the number of orbitals, we can keep going, but we only needed 4. So there's quite a few options here for us to determine what's different about these two. There's also a couple of more options for similarities. So if you found something different that you wanted to include, awesome. There are other options. I'm just giving you quite a few. And now we can go ahead and look at our sulfur versus our oxygen. So I have both of those element symbols again, remembering that we want to find the protons, the neutrons, and the electrons. On this one, it does make it a little bit easier since we've already done 2, but we have our atomic number, our number of protons is 8, which means our number of electrons is 8. This one makes it really easy again because they're zeros, so we don't have to look at them. And now it becomes 16 minus 8 for our mass number minus protons, which again is 8. So we have 8 protons, 8 neutrons, and 8 electrons. In our nucleus, we're going to have our 8 protons and 8 neutrons. in our orbitals around the nucleus. Our first orbital gets a total of how many again? Awesome, it does get a total of 2 electrons. Then we have to add a new orbital because we're not done. And this one can get the rest, and we have 8 total. We already have 2, which means we need 6 more. So you have a total of 8 electrons, 6 of them are valence electrons. Now for sulfur, we're gonna look again at our atomic number or number of protons. And our protons is 16 for this guy. Our neutrons, we're gonna skip over. We're gonna look at our electrons because we know if there's 16 protons, we need 16 electrons. Again, because this is less than 5, we're going to get rid of our decimal. It becomes 32 minus 16. And 32 minus 16 is going to be 16. All right, so now what we're going to do is we're going to draw a nucleus again. All right, and we have protons and neutrons in the nucleus. So we have 16 protons and 16 neutrons. Once we have that, we're going to draw our first ring or our first orbital. How many electrons go in that first orbital? 2. Then we add our second orbital. How many electrons can go on the second orbital in total? We can have up to 8 electrons in the second orbital. So we're going to add 8 more electrons. Are we done? No, we are not done because we also need our third orbital because we need 16 total electrons. We only have 10. So we're going to add 6 more. Electrons to make sure we have 16. Again, we're looking for similarities and differences. If you would like to just write the exact same ones or very similar ones, the only difference being that there are only 6 valence electrons now. So similarity, 6 valence electrons. Our differences, number of protons, neutrons, electrons, orbitals, mass number. All of those are different values. So all those help us find different things. If you have any questions on this, let me know. And then we do remember have our summative on Friday. So make sure you guys are working on that review as well.